Well, welcome to our first video in a series on trig. Tonight we're really just going to hit some basic trig facts. So some common terms we've talked about. Our initial side is the side at which the angle of rotation begins. And I'll draw it in blue here for you. Okay, you always want to make sure you draw that initial side in. The terminal side is the, the side at which the angle ends. And we'll draw that one in red, so perhaps it ends in quadrant 2. And we refer to this as standard position. So you always want to show which direction you went in and label that angle theta. Okay, so again I have my initial side and my terminal side. So we should be able to sketch angles pretty quickly. Notice this one says negative 220, so make sure you always begin again by drawing your initial side. And I want to go backwards basically 220 degrees. So remember, this total makes 360 degrees. Divided by 4 makes each of these corners 90. You should see 4 90-degree angles. So because I'm going backwards, I'm going to start at 0 degrees. I'm going to label this negative 90, negative 180, negative 270, and then again back to negative 360. So if I want to go 220 degrees, I know I'm going to go 90, another 90 makes negative 180, and I'm going to be a little closer here. And there's my terminal side. Now you have to show where that angle of rotation went, so I want to be very clear I went this way, and I'm going to label that theta. Now 400 degrees, you might be thinking, well, how do you graph 400? Well, again, you're going to start with your initial side. We're going to go positive 400. Now, remember, this is 360, so I'm going to go around once. I'm going to show that I go around once. So there's 360, and now I'm going to say, okay, 400 minus 360 gets me 40 degrees, so I have to go another 40 degrees. So if this is 0 and this is 90, halfway would be 45. So I'm going to go just a tad under that and continue this to say that theta is 400 degrees. Okay, coterminal angles. We talked about these quite a bit early on. So here's a quick example. Graph 120 degrees and negative 240 on the same graph. What do you notice about the terminal side? So again, here's my initial side. I'm going to start with 120. So I'm going to go 90. That's 180. So I know I'm going to go less than that. So I'm going to finish this one in blue. So I'm going to say, okay, positive 120 degrees in that direction. Now I need to go negative 240. So here's negative 90, negative 180, and negative 240 gets me to be exactly on that same terminal side. So how can you define coterminal angles? They are basically angles that have the same terminal side. So the quick way we said to get them was basically you just keep adding or subtracting 360 degrees and you can get as many coterminal angles as you want. So we spent a lot of time in degrees, but then we converted to radians. So it's very important that you understand what a radian is. So let's get this definition written out. What is a radian? A radian is the measure of an angle that when drawn as a central angle of a circle intercepts an arc whose length is equal to the length of the radius of the circle. So once you've got that highlighted to yourself, written out, I want you to highlight this part, whose length is equal to the length of the radius of the circle. That is truly what a radian is. So for example, if you were to grab a piece of string and you measure from the center over here, and we call that your radius, and then we take that string and we stretch it out on the arc of the circle. If those two are equal, that is referred to as 1 radian. Okay, now, watch this. Let me draw the best circle I can here. Well, that's not the best I can do, I guess. Here's what should happen. Remember, this is 0, 90, 180, 270, 360. Okay, and you've got to know these in terms of radians, in terms of pi. Well, here's where pi kind of came from. If you measure, and again, this is not drawn to scale, if I were to measure this length of the radius, and I were to then take it like as a string, I put a string on there, measure it out, and then I go ahead and I measure out the same radius. So there's 1, 2, 3, and I should have a little extra left over. This is where pi actually comes from. Pi is equivalent to 3.14, which is equal to 3 and a little more radii get me to pi. So it really is a big idea that you understand what a radian is. It's when the radius is equal to the same length on that arc. Now, we do have to be able to convert from radians to degrees and degrees to radians. So let me just remind you, if you have currently degrees and you want to go to radians, basically what we say is whatever we want goes on top. So if I have 40 degrees and I want to convert that to radians, I simply multiply by what I want. I want a radian, which is pi over 180. Okay, so if I have degrees, I multiply by what I want. I want radians, pi over 180. If I have radians and I want degrees, so let's say I have 2 pi radians, and I want to convert that to degrees, remember what you want goes on top, so I'm going to multiply by 180 over pi. And again, this is a quick review, but in essence, that's what we're doing. So we'll try a couple quick examples here. If I want to take 50 degrees and convert to radians, I'm really doing 50 times I want a radian, pi over 180. Now, here's the quick method. 0 on top, 0 on the bottom, those cancel. So on top, when I multiply, I get 5 pi, and on the bottom, when I multiply, I get 18. So that is 5 pi over 18. Let's try this bear here. Negative 2 pi over 5. And I want to convert that to degrees. So what I want goes on top, so I'm going to multiply by 180 over pi. And I'm going to cancel first. I've got a pi on the top, pi on the bottom. Those cancel. I'm going to just simplify my arithmetic. I'm going to say 5 goes into 180 36 times. So when I multiply on the top, I get negative 72 degrees over nothing. So it's negative 72 degrees. All right, again, as a quick review, what does the term reciprocal mean? Well, reciprocal means basically that you are going to flip your fraction. So what are the 3 trigonometric ratios that we should know for sine, cosine, and tangent? Well, remember we said SOHCAHTOA, so sine is equal to opposite over hypotenuse. Cosine is equal to, and I just want to be clear, it should be cosine theta. It should be sine theta. Equals adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. Okay, so those were our 3 basic ones. Now you do need to know the reciprocals. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So if you wanted to represent cosecant down here, you just take the opposite of sine. So this would be the hypotenuse over the opposite. If I wanted the reciprocal of cosine, which is secant, you're literally just flipping your fraction. So again, hypotenuse over adjacent. And the reciprocal of tangent, which is cotangent, would be adjacent over opposite. All right, so we can apply those to a problem real quickly. Find the values of the 6 trig functions of angle A. So they'll tell you an angle, you just got to mark it down. So I'm going to mark angle A. Everything is based off that angle. So the first thing I always find is the hypotenuse, which is across from the right angle. So I'm going to put a big H there. I usually find adjacent next because adjacent means next to your angle. And there's always 2 sides next to an angle, but once you've labeled hypotenuse, it makes the other one pretty obvious that that's your adjacent. And opposite actually means across from. Now, you'll notice I don't have all the sides. So I'm going to do a quick Pythagorean theorem. A squared plus B squared equals C squared. Just remember your c squared has to be the hypotenuse, so that's my 13 squared, my 12 squared plus my b squared. Now this is a triple that you should know, so I'm just going to go ahead and put my 5 there because I know my triples. So now that I have everything labeled, I can go ahead and find all 6 trig functions. So I'm going to start with sine theta. Remember, theta is where I marked my angle. So I'm saying SOHCAHTOA, O over H. So I'm going to say that's 5 over 13. Cosine, ca, adjacent over hypotenuse. So I'm going to go with 12 over 13. And tangent is opposite over adjacent. So hopefully you've got 5 over 12. Now once you have those, remember the reciprocal functions are super easy. Just got to remember who goes with who. Tangent's the obvious one. That's called cotangent. And again, I'm just taking its reciprocal, so 12 over 5. Sine is called cosecant. Remember, anything that starts with a C is represented by co. So again, that would just be 13 over 5. And then cosine, I kind of just reverse the order. That's secant. That's going to get me 13 over 12. But we've labeled our 6 trig functions. Well, I think that's actually going to do it for us tonight. Remember, our whole goal was to just get some basic trig ideas down. And the next 2 nights, we'll really dive into some nasty trig. We'll hit the graphs and then all the special identities. So have a great night, and we'll see you tomorrow.